The third quantum number is the magnetic quantum number, and it's got symbol m sub L. And it tells us which way the orbital is pointing in space. It's called the magnetic quantum number because specifically it tells us how it's oriented relative to a magnetic field, if you put a magnetic field around the atom and the electron. But we don't need to worry about the details of that. Now, it depends on the L value. So when they say magnetic sub L, it's telling you that it's depending on the L, and here's how it depends on it. M sub L can go anywhere from minus L up to 0, up to plus L. So for all the L values that we have, let's write all the M sub L values that are possible for them. Suppose we're in the fourth shell. That means n equals 4. Let's list all the L values that we could have. Now L can go from 0 up to n minus 1. So L can go from 0 to 1 to 2 to 3. And in the last video we saw that you could name these subshells. Each one of these is giving you a subshell. What you have here is a 4s subshell. Here you have a 4p subshell. Here you have a 4d subshell. And here you have what? A 4f subshell. Now the M sub L values that you can have are minus 0 to 0 to plus 0 for this. So the only M sub L values that you're allowed to have for this one is just 0. How about this one? You can go from minus 1 to 0 to plus 1. So there are 3 possible M sub L values. For this one. How about this one? You can go from minus 2, minus 1, so you just count up through 0. And then for this one, now, what's important, you should be able to list the M sub L values that go with any L value. Now what's important about this though is not the M sub L values themselves or which orientations these correspond to, but these tell us how many different orbitals are in the subshell. So here we have the subshell. If we have only one M sub L value, that means there is only one orbital in the 4s subshell. So 4s subshell only contains one orbital. 4p subshell contains 3 orbitals because there are 3 values. What do these look like? Well, each of these corresponds to a different orientation of the orbital in space. It's pointing a different way. The p's look like dumbbells. So there are 3 p's. One of them is going to look like this along the z-axis. Another one here is going to look like this along the x-axis. And then there might be one coming in and out of the paper here along the y-axis. All these would be at right angles to each other. So those would be the 3p orbitals that are in the subshell here. Now how many different d orbitals can you have? Well, there are 5 different M sub L values. So that means that there are 5 different orbitals in a d subshell. So it's determining how many orbitals are in a subshell. That is the important thing about the M sub L. How many orbitals can you have inside the 4f subshell? Count how many M sub L values you've got. You've got 7. This is worth remembering, and we'll use it over and over again later. Whenever you have an S subshell, it contains 1 orbital. Whenever you've got a P, it contains 3. Whenever you've got a D, it contains 5 orbitals. And an F in any shell contains 7 orbitals.